In this chapter, we'll explore what object-oriented programming is all about. Without the structure that OOP provides, you might find yourself repeating the same code in different places, writing overly complicated functions that try to handle too many tasks at once, and making parts of your code visible that should remain hidden. All of this makes your code harder to organize, more confusing to work with, and more likely to contain mistakes. Let's learn the object-oriented programming. Object-oriented programming, or OOP, is a method of organizing and structuring code to make it simpler to manage, easier to understand, and more convenient to reuse. Let's break down that statement in a way that's easy to understand. Imagine you're organizing a large project. Think of a big project, like planning a large event. There are many different things you need to keep track of: the guest list, the schedule, the budget, and the tasks that need to be done. If you just wrote all of this information down in one big list, it would quickly become overwhelming and hard to manage. You'd have to sift through a huge pile of details every time you wanted to find or update something. Object-oriented programming is like a method to break down that big project into smaller, more manageable parts. Instead of having one huge list, you create categories or sections for each major part of the project. Following are the categories: organizing, structure, managing, understanding, reusing. Organizing, OOP helps you group related information and actions, like creating separate sections for guest details and event schedules, making it easier to find and manage specific details. Structure, each section follows a structure, like a guest list with name, contact details, and RSVP status. This consistency ensures that information is stored predictably, similar to creating a class in OOP to define data structure. Managing, with everything organized into well-defined sections, managing is easier. You can update guest details without affecting other areas. OOP simplifies updating, maintaining, and expanding code without disrupting the rest of your project. Understanding, if your project is organized into clear sections, it's much easier for others to understand and navigate. OOP makes your code more understandable for everyone. Reusing, you can reuse the guest list from a previous event by simply copying and tweaking it. In OOP, this is like reusing classes and objects in new projects, saving time and effort. Object-oriented programming using the real-time example of a coffee shop's point-of-sale system. Classes, the blueprints. In a coffee shop POS system, you have different components like menu items, orders, and staff. Each of these components can be represented by a class. A class is like a blueprint that defines what something is and what it can do. Real-life example of classes. Menu item class. This blueprint defines what a menu item is. It might include attributes like name, price, and category, for example coffee, pastry. It also includes methods like apply discount and update price. Order class. This blueprint defines what an order is. It might include attributes like order number, list of menu items, and total amount. Methods might include add item, remove item, and calculate total. Staff class. This blueprint defines what a staff member is. It might include attributes like name, role, for example barista, cashier, and employee ID. Methods might include clock in, clock out, and process order. What is an object? An object is a specific instance of a class. If the class is the blueprint, the object is the actual item you interact with in the POS system. Here are the object examples for POS system. Latte menu item object. This is a specific instance of a menu item. It might be a latte with a price of $4. You can apply a discount to this latte or update its price. Order number 101 object. This is a specific order. It might include a latte, a croissant, and a total amount of $6.50. You can add or remove items from this order and calculate the total. Emily Johnson, staff object. This is a specific staff member. Emily might be a cashier with an employee ID of C123. She can clock in and out and process orders. Inheritance, reusing blueprints. Inheritance allows you to create new classes based on existing ones, adding or modifying features. Let's continue with coffee shop example. Discounted menu item class. Suppose you want to create a class for menu items that have special discounts. You can create a discounted menu item class that inherits from the menu item class. It might add attributes like discount percentage and methods like apply discount. Now, when you create a discounted menu item object, it has all the features of a regular menu item plus additional discount-related features. Encapsulation, keeping details private. Encapsulation means keeping some details hidden inside the object, so they can't be accessed or changed from outside. In your POS system, how the total amount for an order is calculated is managed internally. You interact with the system using simple functions to add items and get the total, but you don't need to know the detailed internal calculations. These details are encapsulated within the order object. Polymorphism, same action, different behavior. Polymorphism allows different objects to respond to the same action in their own way. Imagine the action, process, in your POS system. Different items respond differently when processed. Process a menu item, it might add it to the order and update inventory. Process an order, it might finalize the total amount, apply taxes, and generate a receipt. Even though the action, process, is the same, each item, menu item, order, handles it in its own way. Putting it all together. In a coffee shop's POS system. In a coffee shop's POS system. Classes are like the blueprints for different components, such as menu items, orders, and staff. Objects are the actual items you interact with, like a specific latte or a customer's order. Inheritance allows you to create specialized versions, like discounted menu items, by building on existing blueprints. Encapsulation keeps certain details, like how order totals are calculated, hidden within the object. Polymorphism allows different items to respond to the same action, like process, in their unique ways. Object-oriented programming helps organize and manage the various components of a POS system, ensuring they work together efficiently and can be easily adapted or extended with new features. Thanks for watching the Coder Therapist. Do like and subscribe for more updates.